Okay, good morning, everyone. How did the homework go? Any questions? Okay, I'm just giving a few seconds for everybody to join in. Okay. So I will start with the following question just to make sure you got both equations going. So my question is the following. For each equation below, okay, so for each of the equation below, okay, the question is decide if it's a circle or an ellipse. And in every case, you have to tell me the radius, the A and the B. So for each equation below, decide if the graph is a circle or an ellipse. Or ellipse, okay? So I start with the first one. Of course, the very basic one. Suppose I give you x squared plus y squared equal to 4. Okay, this means if I take all the points that satisfy this equation, circle or ellipse, and the center and the radius, if it's a circle, A, B, elongated vertically or horizontally if it's an ellipse. So please, I want the answers very quick on chat just to make sure we're all moving along the same lines. So circle or ellipse. Okay, anyone? Okay, it's a circle. What's the center? And what is the radius quickly? Okay, what's the center and what's the circle? What's the radius? Center is at the origin and the radius is 2. All right, so that's the basic one. Now let us say I give you the following. 4x squared plus 4y squared equal to 1. So not in a very, very standard format, with a little. Is this a circle or an ellipse? And circle, center and radius, ellipse, the A and the B. Okay, Aaron tells me a circle because. Aaron, can you speak?
Yeah, I can.
Okay, please go ahead. Why is it circle?
Because there's no A and B under it.
Okay, what else can we say? But
and because
you had 4, I mean, it's the standard form of a circle has to be x squared, if it's centered at the origin, equal r squared. All right, it has to be that. So the question is, if you tell me it's a circle, you have to write it for me in this format. Can we do that?
Yeah, you would just end up dividing out the 4s. You would simplify it.
Right. And no, divide by 4. Divide by 4. Absolutely correct. And now it will have this format. Okay, so it's not because there is no A and B, because I can play a game and I can put here a 3, for example. There is no A and B, but this will not be a circle. Let's make it a circle is because I have 4 and 4. 4x squared, 4y squared. So I divide by 4 across, I will have x squared plus y squared equal 1 over 4. Now I have an honest to goodness circle, center, the origin. Aaron, what's the radius quickly?
The radius would be 1.
No.
Oh, sorry, I'm sorry.
That's
It'd
fine.
be 1/4.
No. What's the radius, all of you?
Oh, 1/2. Sorry, yeah, because you have to divide it by. Yep. No, sorry.
It's the square, so you'd have to take the square root. This is 1/2. Okay, so it's the square root of it. That's how you get the 1/2. All right, so now more. Suppose I give you x squared over 4. Very basic one. All right, what is this? Ellipse or a circle? Obviously. Please, I want quick answers because those are not hard questions. Okay, that's an ellipse. What's the A in this ellipse? What's the B in this ellipse? What's the center? So I want the A and the B, I want the center. And is it elongated? Okay, is it elongated vertically or horizontally? So like that's there. What's the A very quickly in this? That's okay, Jacob. What's the A in this scenario? The A is, this is the A square. So the A is going to be the 2. This is the B square. So the B is going to be a 4. And how is it going to be elongated, you think, horizontally or vertically? Okay, so when we're going to sketch the circle, we're going to sketch the ellipse, it's going to be centered at the origin. The B, this is the B, because if x is equal to 0, so if I take x equal to 0, y squared over 16 is 1. It means y is going to be plus or minus 4. And this is going to be the A. That's the picture always in the ellipse. So it's going to be definitely elongated vertically in this case. So A B is bigger than A, elongated vertically. Okay, so the A and the B are the distance from the center all the way to the edge. That's the A on the x-axis, and that's the B on the y-axis. All right, now suppose I give you the following. Okay, this is a little bit hard, I think, but it addresses one issue. It addresses the problem that one of your classmates, when I gave you this question, told me that this is a circle because there is no A and B. And I objected to that. I thought it's a circle because we have to divide by 4. So what about this one? This is a little bit harder, but that's all right. What do you think is going to be? What do you think is going to be the A and the B? Okay, so one student tell me divide by 36. Why would I divide by 36 if I have a 1 in here? So do you think it's going to be an ellipse or a circle? Okay, so let me show you what guy of game this is going to be. This is going to be an honest to goodness ellipse. And how we're going to see it as an ellipse, we don't have x squared over a squared plus y squared over b squared. We don't really see that. We see something fairly similar to it. So how are we going to get the a squared? And this is the trick that we're going to do. I cannot divide by 36 because I have 1 to the right. If I had 36 to the right, you know, that will be correct. So I'm going to play games. I'm going to rewrite this in the following format. Watch how I'm going to rewrite it. I'm going to rewrite it as x squared divided by 1 over 4. Okay, am I algebraically correct? Am I algebraically correct? X squared divided by 1 over 4, it means that's x squared multiplied by 4 over 1. It's the same thing as 4x squared. Okay. So I am mathematically correct. Plus, this one also, I can rewrite it as y squared over 1 over 9. Okay, so here, I cannot divide by 4. If I divide by 4, I can make this x squared, but I will not make this y squared because I have a 9. So this is contrasted with that problem. If x squared, y squared are multiplied by the same number, now we're going to end up with a circle once I divide by 4. If it's not the case, I'm going to end up actually with an ellipse. All right? Now what's the A? And what's the B? Who can give me the A and who can give me the B quickly? So remember, this should be play the role of the A square, and this will play the role of B square. So what's going to be the A in this scenario? What's going to be the B? So A squared is 1 over 4. it means the A is the square root of 1 over 4. The square root of 1 over 4 is a half. B squared is going to be 1 over 9. B is the square root of 1 over 9, which is 1/3. Okay, so the reason I give this problem is to address the issue that we came up with before. This still an ellipse, but we have to play a game to make it into an ellipse. We can rewrite it this way, and that will be a honest to goodness ellipse. All right. If I move the paper faster than I should, please let me know. All right, more questions? This one. Again, ellipse or a circle. If it's an ellipse, you give me the A and B and the center, and if it's a circle. Okay. All right, now all of us, is it an ellipse or a circle? Of course, this is not a hard one. Please, all of you, I want answers from each one of you. Okay, Asia, it's an ellipse. All right, what's the center? Can you talk, Asia? So that's an ellipse.
Yes, I can see.
Center. That's the form x minus h squared. That's an ellipse which is being shifted so that we change the center. Equal to 1. So what is the center? It means the center here is h and k. What's the center in this case? What's playing the role of h? Is it 1? What's going to be the other component? Asia, can you figure it out?
It would be -2.
With -2. What's the A? And what's the B?
The A would be 1, and the B would be the square root of 5.
Absolutely correct. So now if I need to sketch this ellipse, so it means if I want to sketch all the points that satisfy this equation, it's really very hard, but we're gonna graph it. Once we know it's an ellipse, we can graph it. The center is at 1 minus 2. This is the 1 minus 2. So that's the center of my ellipse, the center. A tells me how much, so this is a 1 here. A tells me how much we should move this way. So 1 unit from here, 1 unit from here. That will give me the 2 vertex. And then the B, so this is the A. The B is the square root of 5. Now square root of 5 is a little bit over 2, something like 2.2. So that's the square root of 5 from here to here. And that's the B. So this is the B, which is the square root of 5. And then it's symmetric right here. So that's going to be my ellipse. It's going to go this way up to here. Okay, it means if I take every point on this picture, satisfy this equation. All right? Okay. Now, what we're going to do is what we did for the circle. It means we're going to have what we call ellipses in disguise. So I'm going to give you an equation that doesn't look like an ellipse, but at the end it is an ellipse. So actually, I want to give you one more question. Sorry, one more before I proceed to ellipse in disguise. One more question. Suppose I give you the following. X squared over 4 plus y squared over 4 equal to 1. Okay, my last one. Question is again, is it an ellipse or a circle? Back to you. Anybody else? So what's happening here, the A is equal to the B. So when the A and the B are the same, actually this is becoming the circle, the ellipse. When the A and the B are equal, the ellipse is actually nothing more than a circle. So here, if you multiply across by 4, we get this is equal to 4. It means the circle. So in an equation of an ellipse, when the A and the B are equal, and the A and B are equal, it means from here to here and here to here, they are the same, then my ellipse actually turn into a circle. So it's a remark that I want to make sure you guys are getting it. Right now, as I say, ellipse is in disguise. So I'm going to give you an equation that has nothing, doesn't look like an ellipse like we did with the circle, but we're going to make it into an ellipse by completing the square. So ellipse in disguise. I think I misspelled disguise, but you guys know. So the following equation represent the equation of an ellipse. And the question is, write it in standard format. So the equation below, I'm telling you that it's an ellipse, is the equation of an ellipse. The question is, write in standard format and then find the A and the B and the center in standard form. Now let me make sure. When I say standard form, I mean this form right there. So when I say standard form, that's what we call the standard form. So this is my equation. I'm going to do two equations. 4x squared plus 8y plus y squared equal to 0. Okay, now if you look at this, of course, this is not an ellipse. It doesn't look anything like an ellipse, right? The way we're going to do it is exactly what we did for the circle. We're going to complete the square to make it look like an ellipse. So I will do the first one myself. All right, how are we going to complete the square? For I will put the x's together. Those are the x's and the y. So I'm going to rewrite this into y squared plus 8y equal to 0. And the idea is basically the idea of completing the square that we developed last time. So this term is nothing because at x squared, there is no x term. This piece, I need to complete the square for it. Now, how shall I complete the square? What should I add to complete the square? And I added both sides. What should I add? Let us remember, what do we do? Okay, I add 16. Everybody agree? It's what y multiplied by, which is 8, divided by 2, it's 4, square it, 16. I added, to keep the picture clear, the equality clear, I have to add it to both sides. Now, once I do that, I will have the following. So this will become 4x squared. Okay, and this would become what? The second term become what? Please write it up. This become which quantity squared? Which it's become y plus the 4 squared. This is the y. What you put here is half of what y is multiplied by, and you keep track with the sign. Positive, positive, negative, negative, and half what's y multiplied by. Y multiplied by 8, half of it is 4, okay? So this is gonna be equal to 16, right? Now, slowly, slowly, we're getting close to the equation of an ellipse. Now, how can I make this into equation of an ellipse? What shall I do? I better you guys answer my questions. Anthony, what shall I do now? Now we're gonna divide by 16. Hopefully we can get exactly a circle. So we divide by 16, I will have 4x squared over 16 plus over 16 equal to 16 over 16. Now, this term, there is nothing. We're done with that term. That's clear. 16 over 16, it's 1. So I'm guaranteeing the right side as well. Now, 4x squared over 16, this is 4 times 4. This will give me with x squared over 4. And now this is an ellipse in the standard form. Okay, so now what's the center? All right, the center here. That's a 0 from here and a -4. Now what's the A? This is A square. Means the A is equal to 2. What's the B? This is B square. It means the B is equal to 4. So now I have an ellipse centered at 0, -4. This is the A and this is the B. This is again is going to be elongated vertically because the B is bigger than A. So B bigger than A is going to be elongated vertically. Okay. Now we're going to take another one. It's a little bit harder than that, but it's the same principle, but I will tell you what is it a bit harder about it. Okay. So this is an equation. Didn't look like an ellipse. By manipulating a little bit, we totally view it as an ellipse. And we use the principle of completing the square. All right. I'm going to do another example. As I said, it's a little bit harder, but you guys follow me quickly. Follow me. When we completed the square, I completed the square of an expression of the form x squared, means the coefficient of x square is 1 plus bx. And to complete the square, I told you that you're going to add, that's how we complete it. We add half of b squared. And if we do that, we get x over half of b squared. That's really the principle of completing the square. But the coefficient of x has to be a 1. So now I'm going to take the following equation and I'm going to complete the square. So this is an equation for x squared plus 8x plus 16y squared minus 32y equal 44. It looks absolutely a nightmare, but we're gonna rewrite it so that it have this form. Okay, that's really the goal I'm going to do. All right. First, we put all the x's together and all the y's together. And now how are we going to complete the square? Listen very carefully because you will have to be responsible. Completing the square requires the coefficient of x squared to be 1. So to use this algorithm, x squared has to be multiplied by 1. But here I have a problem because x squared is multiplied by 4. And here I have a problem because y squared multiplied by 60. How can I remedy that problem? What shall I do to be able to remedy this problem? If I divide everything by 4, it's not a bad idea, but the 16 will still have 4 in front of it. Okay, so if I divide by 4, I will follow you verbatim. I will divide by 4. I will have x squared plus 2x. You're absolutely right. But then when I divide by 4, I'm going to have 4y squared. I divide by 4, this is going to give me 8y. I divide by 4 equal 11. So I can make it simpler, but where do I will still have a problem? Back to you. Where do you think I will have a problem? Okay, I'm going to divide by 4. I don't have to, but I will do what you guys are suggesting. So I'm going to divide by 4 across. When I divide by 4, I have to divide every single term by 4. I will get x squared when I divide by 4. 8 over 4 will give me 2x. 16 over 4 will give me 4y squared. 32 over 4 will give me 8. 44 will give me 11. Okay, now step number 2. I need to complete the square. This piece is easy. So this one, I will have x squared plus 2x. What shall I add? And everything I do to the left, I do to the side. What shall I add to this to complete the square? This is x, coefficient is 2, divided by 2, give me a 1. Square it, I add a 1. So this one, I'm going to add a 1 right there immediately. Plus. What can I do here? The algorithm works only if y squared is multiplied by 1. Now, if y squared is multiplied by 4, what I'm going to do, and then watch carefully how we're going to do. Step number 1, I'm going to factor out the 4. I'm going to factor out the 4. So listen very carefully, not the 4y. I will factor out the 4. When I factor out the 4, what will I have inside? I will have y squared here. And this will give me what? What shall I have here? Please help me out because I want to make sure you guys are following. If I factor out the 4, that's going to give me 4y squared, and that will give me 2y. Okay, so step number 1, I had to factor out the 4 because I want to complete the square. And the algorithm I gave you to complete the square only work when y squared multiplied by 1, not by 4. So I factor out the 4 so I can use my algorithm here. Now, this first piece is not problematic. That's x plus 1 squared. So I'm done with the x's. It's this one which is going to be problematic. How can I complete the square of the one inside? It's y squared minus 2y. To complete the square of this, I have to, y is multiplied by minus 2, half it, minus 1, I square it. So half b and square and add. So it means here I have to add, what should I add? I need to add 1. Now, this is the big, why did you plus 1 for the first part? Which one? Which plus 1, Kishan? Tell me where. This one?
The x squared plus 2x plus 1.
Because I want to complete the square of this piece. How do I complete the square of that piece? What should I add?
Plus 1.
Right, and I added both sides. Did I answer your question?
Okay, so we only do that, like we only plus, I don't know how I want to say it, but like, so to complete like a perfect square or whatever, we just add that to complete it on both sides.
Yes, because I want this piece to become x plus 1 squared. So I had to add 1 to x squared plus 2x. But I have inequality. So I have to do it both sides, otherwise the equality falls apart.
Can we do another one like this?
Yeah, we're going to do one more like that. But first I have to finish this problem. I'm not done yet. Okay? All right. So this is x plus 1 squared. Now the problem is here, and watch very carefully. I added 1 inside the parentheses. What should I add here to compensate? That's why I'm thinking this is a little bit hard. What did I add here? Anybody else? Watch, when I add 1, I actually not adding 1. I'm adding a 4 because 4 times 1 gives me a 4. So what I'm adding here, actually here, we're adding the 4 times 1. So we're adding a 4, we're not adding the 1. So that's the hardest part in this problem, is that because I factor out the 4, so inside the parentheses, I added 1, which is equivalent to add a 4 to the whole equations. Once we get that, the rest is going to be relatively simple for us. So now I'm going to have x plus 1 squared plus 4 times y. This will become minus 1 squared equal, this is 1 and 1, so I try to make it simple. So it's going to give me a 16. Now I have basically my ellipse, divide by 16 across. And I will have x plus 1 squared over 16 plus y minus 1 squared over 4 equal to 1. And now my ellipse is in a standard form. Okay, so the hardest part is at this stage when my plus 1, it means I'm actually adding 4 because the 4 is being factored. And now that's an ellipse. And the center is minus 1 and 1. The a, that's the a squared. It means the a is the square root of 16, which is a 4. The b is the square root of 4, which is equal to 2. So this is an ellipse, it's gonna be the horizontal ellipse, not a vertical one. So this is gonna look like that. The center is -1 and 1. That's really my center. My A is 4, so I have 1, 2, 3, 4. That's my A. So I have to go. And my B is 2. So I'm gonna go up here by 2. That's the B. And it's gonna look something like that. And that's the ellipse I will be after. Okay. All right. So I will do one more because your classmate is asking me for one more. So, and I will do that. So this is my problem. But I'm gonna pick something which is not very hard. So I will not. So suppose I will give you, I'm gonna give you one not very hard to make sure you guys get the point. But you have to give me a minute. So I don't give you something impossible. Plus 16t squared. Right, so x squared plus 16y squared divided by 64y. All right, I'm gonna try this one. I hope it will work because not everything I plop in will be an ellipse. All right, so I'm gonna try this one. If there is anything wrong with it, I will fix it as I move on. Okay, all right. This is an ellipse, and my question here is write it in the standard format. All right, I give you a minute, all of you. I mean, 2 minutes to try to do your best with it, and then I will take it on myself. So every one of you try to do your best with the problem. Okay, while you guys are doing it, I will do it myself to make sure I gave you a decent equation. Okay. Anybody is getting anything so far? I'm stuck. Yep. That's why I'm giving you another one. Anybody else? Anybody like to lead? Divide by 16.
If you, to complete the square root or the square for y, you would have to divide the whole thing by 16.
Okay.
Which would cancel out y squared. or it would cancel out the 16.
If you want to, you don't have to. Okay, divide by 16 or complete the square. So I'm not going to divide by 16, Aaron. All right, even though I can make it up, because I want to basically tell you what to do without dividing by 16. Are you with me? Okay.
Yeah.
All right. So what I'm going to do without dividing by 16, because sometimes you won't be able to save the day with this approach. So I have to make it both of you. Instead of dividing by 16, what do you think I'm going to do? I'm going to factor the 16. You see what I did? Now, if I factor it, what do I get inside? Help me out. Remember, whatever, 8th grade, 5th grade, I don't know where you study this stuff. When I factor the 16, what will I be left with in here? So this 16 is multiplied by y squared. So I'm going to be left with the y squared minus 64. 64 is 4 times 16. So I'm left with 4y. All right. Now I'm going to complete the square of this piece inside. All right. This one, we have to complete it. So I will do that here. Then I copy y squared minus 4y. What should I add to get a complete square? All right. So Kishan, listen to me. What should I add to? I have to take coefficient of y, which is a minus 4, divided by 2, which give me a minus 2 squared. Minus 2 squared will give me a 4. So I have to add the 4. But what do I end up with? I will end up with 1 minus, because there is a minus 2 squared. All right, so the way we complete this is going to give me 1 minus 2 squared. So now I'm going to proceed here. Times. If careful, the 16 is out. So it's going to give me y squared minus 4y. And then I had to add the 4 to get that. Now here's the problem. What should I add to the right? I manipulated this. What should I add here? So now you have to think. Basically, what did I add to the left? No, Kishan, that's not 16. What did I add to the left side? That's 16y squared. That's the minus 64. So what did I add actually? I added 16 times 4. That's what I added to the left. I did not add 16. I added 16 times 4, because when you multiply out, you get the 16y squared minus the 16y, but you actually added 16 times 4. That's what you have to add to both sides. How? Think about it a little bit, one more time. So here on the side, let us think. Okay. My goal is not to change. My goal is to rewrite, to manipulate algebraically. So in this expression here, when I minus 4y plus 4, okay? If I distribute again, what do I get? 16y squared, which is this term, minus 64y, which is this term, plus what? Kishan, answer the question. Plus what when I distribute? 64. So what did I actually add to this term? I added the 64. What is the 64 coming from? It's the 16 times 4. That's what I added to the left. That's what I have to add to the right. Okay, all right. So now we go back to our equation. Now everything is done. So I'm going to have, so that's the only hard part in those problems, is that to be careful is what you are adding. You're adding the 16 times 4. That's really what I wanted to be careful with. So now I complete fully squares and I get my nice ellipse. Now 16 times 4, that's a 64. And this is the y minus 2 squared. I am not changing anything. Those two expressions and this are exactly the same. I'm just manipulating algebraically to be able to see an ellipse in this equation. Okay, now finally we divide by 64 because we want an honest to goodness ellipse. and that will give me x squared over 64. Every term has to be divided. Plus, so I'm dividing each one by 64. This one by 64, and this one by 64. Everything has to be divided. This gives me a 1 in here. 16 over 64. Now 64 is 416. So it's going to give me 1 minus 2 squared over 4. And this is the standard form of the ellipse that I am actually after. All right. So now the center is easy for us. It's going to be 0, 2. And the a square is 64. A is the square root of 64, which is in 8. So I'm giving you nice numbers here. And the b is the square root of 4, which is equal to 2. And finally, if I'm going to draw my ellipse, I can draw it. I can draw this. The center is at 0, 2. So that's a 0. That's my 2 right here. That's the center. A is 8. It means I need to go 8 unit this side and 8 unit from that side. That's the A. My B is 2. So that's my B, which is a 2. That means this is the graph of this equation. It means every point on this ellipse satisfies this equation, the original equation. If I draw all the points that satisfy this equation, which is very hard for us, absolutely impossible. So, but if I sketch all the points x, y that satisfy this equation, I will get something, and I will get this ellipse. All right. Any questions? So please, I'm going to assign 2 problems along those lines. For homework for next time. Make sure to do them so you will have a good understanding of what to do. Okay. All right. So what we are studying, what we call circle, ellipse, and there is one thing more called hyperbola that I will start today, hyperbola. Those are called conic sections. Okay, and where does the word conic coming from? Okay, why do we call them conic section? The reason is the following, and I want you to try to imagine with me if you can. Suppose I take a cone or a double cone, means something like that. This is a cone, something like this. That's a magic cone, and imagine it's infinite, it doesn't stop. And it's a double cone. That's a double cone. Okay, and I take a cone, because it's I call conic section for the reason, and I try to cut the cone. It means imagine the cone. It means like this is like the egg thingy, you know, the one that we use to time eggs, and cut it horizontally. It means imagine you take a plane and you cut it this way. Cut it. I mean, take it and cut it like this horizontally. What do you think we get? Try the best to imagine in your mind. What do we get? So imagine the thing of the egg. You take a plane and you cut it. No, you cut it horizontally. You cut it like this. That's the part which is hard to show you online. You just cut it horizontally like that. What do you think you get? You don't get a smaller cone. This is a plane. I mean, this is a flat surface. You take a flat surface and you cut the cone. What do you think you get? You take a flat surface and you cut it. Exactly. You're going to get the honest to goodness circle. It's a flat surface. So it means something, you take the cone, you take something flat and you cut it horizontally. Then you're going to get a circle. This is flat. So you cannot get a cone. It's something very, very flat that you cut it with. Now let us say you take this cone again and you're going to cut it. You take a sheet of paper, something flat, and you cut it. But instead of cutting it horizontally, you kind of tilt this a little bit. So something like that. Tilt it. So instead of cutting it with a paper in a horizontal way, We're gonna cut it with a paper by tilting. Take this, tilt it a little bit, and cut it again. Basically, you take this one and you tilt this flat surface a little bit. What we're gonna cut this way is actually, you got an ellipse. Okay, so when you tilt it, you don't get a circle anymore. You're gonna get an ellipse. And conic section is those pictures we get when we take a cone and we take a flat surface and we start cutting it. So if we cut it horizontally, you get a circle. If you tilt it a little bit, just try to think about those a little bit at home, you got an ellipse. That's how we're gonna get ellipse. That's how people started thinking about those ideas before discovering their importance, all right? The last part, which is a little bit hard, is that if you take the cone, again, and you cut it with a flat piece of paper. You take a piece of paper again, but you cut it horizontally with a piece of paper, you get something like that. Something you get from here, you get something like this. It means you get a picture like that. That's what you get. And this picture is what we call a hyperbola. Okay, so imagine a cone, start cutting it with a flat piece of surface. So this is flat, totally flat. If you take a piece of paper, you cut it in a flat way, you get those two pieces, one from the top and one from the bottom. This is what we call the hyperbola. If you slant it, you get an ellipse. And if you take it horizontal like that, you get a circle. So that's where the word conic section is coming from. All right, so we studied circle and we studied ellipse. What we still have to do is a little bit the hyperbola. We're gonna study the hyperbola. Okay, so I will start it today, and next time we spend the whole hour on hyperbola and we will be done with the course. So what is a hyperbola? Okay, hyperbola. Okay, what's hyperbola? Hyperbola are the graph of, I will give you the equation and I will tell you how it looks like. Hyperbola are the graphs of equation that has the following form. So there are equations that has the following form. Okay, x squared over a square minus y squared over b squared equal to 1. Now immediately I contrast it with an ellipse. The ellipse, this is a plus, the hyperbola is going to be a minus. Or instead of starting with x squared, or something like y squared over b squared minus x squared over a squared equal to 1. So they are graph of equation of the following form. Now how the graph looks like, I will tell you how the graph looks like this. Okay. So first I'm going to graph this one, and then next time I will talk about that. The graph would look like this. So this is the graph of that function equal to 1. Okay. Let's see how the graph looks like. The graph looks like that. Okay. Step number 1, I'm going to find, just to give it a little bit of motivation, the x-intercept. What does it mean, x-intercept? X-intercept means if an equation has this form, when does it hit the x-axis? So to find the x-intercept, we're going to say, okay, it hits the x-axis when the y is equal to 0. So we're going to set y equal to 0. I will get x squared over a squared equal to 1. And multiply by a squared both sides. It means x squared equal to a squared. It means that x could be either plus or minus the square root of a squared. Means x is plus or minus a. So the intersect is here and here. It means those 2 points will satisfy this equation. Now the y-intercept. It means when does the graph hit the y-axis? Okay, it hits the y-axis when x equal to 0. Okay, but now if I set x equal to 0, what's the y that satisfies that? Then I will have 0 minus equal to 1. So if I multiply by b squared, I will get minus y squared equal to b squared. Okay, what is the y in this case? So y squared equal to minus b squared. So what's going to be the y? Because I'm trying to find which y will give me x0. So I plug in, so what should be that? So I plug in 0 for x and I solve for y. I got y squared equal minus b squared. Does this tell you anything? Anybody has any comments? Any comment? Can this happen? Can this occur? Is it possible to have y squared equal minus something? No, because this is positive and this is a negative number. So I cannot have y squared to be, so this is a negative number. It means there is no way I can find a y such that y squared is negative because y squared is always positive. So this cannot occur. It means, for us, it means if I sketch all the points that satisfy an equation like this, there is no y-intercept. It means the graph will never at all intersect the x-axis. So how the graph is going to look like? The graph is going to look like two pieces. One piece like that, one piece, and it's going to have another piece. And between minus a and a, which is something I'll work with you next time, a little bit to give you a feeling for it, there is no y that satisfy this equation if x is between minus a and a. So the graph is going to be looking like two branches, one branch here and one branch here, totally separated, and there will be nothing in between. Next time, of course, on Monday, next Monday, we will gonna totally try to understand this kind of a picture, and we will spend the whole hour working on the hyperbola and the problem I will assign from the ellipse. And next Wednesday, it will be a review for your final. So a word about the final. Your final is going to be basically 2 weeks from today. So the final will be on Wednesday, 2 weeks from today, which will put us May 5. So it's going to be Wednesday, May 5. It's going to be comprehensive. It means everything. You're responsible for everything. It's going to be totally comprehensive. A review will be out. So review will be out usually, I think on Saturday in this class, I will have the review at the latest. If I have it before, I will let you know. My review will consist basically on the review for exam 1, review for exam 2. I will put them together, and some extra problem for the material that we did after the exam 2. A lot of you, it will do you a lot of good to start reviewing for the final to push up your grade. So you can do the review. Exam 1 is a very good way to review as well. Exam 2 is a very good way for you. So I advise you to go over exam 1, make sure you can do it. Go over exam 2, you understand it, make sure you can do it. And once you're done with those, go over the review and make sure you can do that. And a lot of you can help it yourself by studying well for the final. If you are in this class, it means you guys need trigonometry. So please do your best to study for that. All right, I think the quiz is on Brightspace now. Please get going. And if you have any questions, let me know. Good luck.